All right, let's take a look at our data table. So this is page 9 in our lab manual. So over here on the left, we've got delta t, and so this means a time interval, and the unit is 1/30th of a second. Actually, one thing about our data tables is we always want to include the units of the numbers that we have in here. And you could either write in the units every time we write a number, or maybe a bit easier is we can just write the units in each column here, which is, it's already done for you in this lab. It's not always going to be done for you. So we've got our units there. The time interval, actually this column is going to be easy because the time interval between every one of our measurements that we want to use here is 1/1/30th of a second. And so we're just going to have 1 just all the way down here because each time interval, again, is just 1/1/30th of a second. It's a little more interesting, our next column here, the value of time also measured in 30ths of a second. And so the initial time, we'll call that 0. Okay, so we're imagining starting the experiment when we start our stopwatch at time 0. After one time interval later, then the current time will be 1/1/30th of a second. One time interval later, another time interval later, it will now be 2/30ths of a second, 3/30ths of a second, etc. Now, in this lab, they use the letter S for the position of the object, in other words, the position of our dots here. And so we're going, again, at time 0, we're just going to define that to be at position 0. All right? Now, what you're going to have to do is to get these numbers now, you are going to have to go over to your data, which is going to look something like this here. We've got these dots, and this will be if that's our first dot, the highest up dot, that will be at the position at time 0, or in other words, position 0. This is a 60th of a second later. This would be a 30th of a second later. And so we would want to measure this distance. That distance is going to go right here, the current position of this next dot. We'll now skip another one, and this will be a second. This will be at time 2/30ths of a second, and we'll want now this position. Okay, remember here's S equals 0. All right, and so we're going to put in some numbers here, and I'll tell you what, maybe I'll just make up a couple numbers here. Let's say that this is 4.1 centimeters, and now let's say we've got 10.2 centimeters. Okay, and we'll have to go and measure all those. We do want to get, I would say, at least 10 data points here in order to, well, we're going to make some graphs later. In order for the graphs to look pretty good, I would say we want at least 10 data points here. Now next, what is this? This is the change in position during each time interval. At time 0, there hasn't been, a time interval hasn't gone by, there hasn't been any change in position, so we can just cross that out. What's the change in position during this first time interval? That's actually going to be 4.1 centimeters. The change in position during the next time interval, it's going to be the difference between these two numbers, or in other words, 6.1. The difference in these two numbers here. 6.1 centimeters, etc. Two more columns here. We've now, this bar up here, this V refers to speed in our lab. Speed measured in centimeters per second, and the bar on top means it's the average speed. It turns out that average speed is defined to be the change in position over a time interval. And so what we would need to do, again, there hasn't been any average speed here, so we don't need that data point. What we would do here, actually let's do a sample calculation, is this would be the 4.1 centimeters, and now our time interval is 1/1/30th of a second. And so when we work this out, that actually the 30, I'm going to multiply the numerator and denominator by 30, and I will get here 123 centimeters per second. It's the average. And so that's what would go right here. All right, we can work through the others. Finally, this last column, we're just going to take the time, the value of time, and square it. And the units have been squared. 1 over 30 seconds squared is 1 over 900 seconds squared. And so this would be 0, 1 squared, 2 squared, 3 squared, etc.